Guys, in today's video we will be correcting your worksheets from throughout the week. So let's start seeing all of them. We're going to start with one of the Wednesday worksheets. So you had this here that explained the same things that we did over the video. What the triangles are called based on their angles. So here we have an acute triangle, here we have a right triangle, and here we have an obtuse triangle. Why? Because this one has three acute angles, this one has one right angle right here, and this one has one obtuse angle right here. So the question that it asks is, what is the sum of all of the angles in the triangles above? So you could do that by doing 70 and 60 and 50 and then 90 and 50 and 40. Or you could just add them 3 by 3. Or you could just remember, oh, the angles of a triangle are always 180. The sum of the angles of a triangle is always 180, like we said. So this is 180, and this is 180, and this is 180. So I could do 180 and 180 and 180, or more quickly, I could do 180 times 3. Get it over with nice and quick. 3 by 0 is 0, 3 by 8 is 24, so you write 4, carry 3, carry 2. Sorry, 3 by 1 makes 3, and 2 that I carried over makes 5. So 540. Did I do that correctly? Yes. Okay, so 540 is the correct answer. Great. That was page 1. Let's move on to page 2. Here. So here it's true or false, basically. The first one says that a right triangle has two acute angles, and that is true. I'm just going to put checks because it's a little bit easier right now. So that's true. Yes, if a triangle has one right angle, then the other two are definitely going to be acute. Next up, a triangle can have an obtuse and a right angle, and this is false, so I'm going to put X. Why is this false? Because if it has uh, an obtuse angle, that means that one angle is more than 90, and then a right angle means another 90, so that's definitely that those two angles together are definitely more than 180. And then there's a third angle to calculate, so that's way more than 180. And as we've said, the sum of the angles of a triangle need to be 180, always, exactly, not less, not more, exactly 180. Next up, the sum of the angles of a triangle are 170 degrees. Now we just answered this. Incorrect. It should be 180. Next up, a triangle can have angles that are 90 degrees, 45, and 45. So here, if it was 90 and 45, that would give me 135, and another 45 would give me 180. So yes, it could have these angles. It very well could have these angles. Next up, even if we know two of the three angles of a triangle, we cannot find the third one, and this is incorrect. We solved exercises like this the last time, where if I know two of the three angles, I can find the third one because I know that altogether they have to be 180. Next up, an obtuse triangle is a triangle that has three obtuse angles, and that is incorrect. An obtuse triangle has one obtuse angle, and the other two have to be acute. Next up, I write what kind of angle it is. Each of these triangles is based on their angles. So the first one has all three of its angles being less than 90. That means that they're all acute. So I would write that this is an acute triangle, or in Greek, oxygonio. Next up, this one has one right angle, so that is a right triangle, or in Greek, orthogonio. Next up, we have a triangle that has one obtuse angle. So in Greek, that would be, sorry, no, let's try English. Obtuse, obtuse, triangle, and in Greek, that would be amphlygonio. Next up, this right triangle has an angle M, so M is here, that's where the letter is. How much is the angle lambda? Since this one is 75, and this one down here is a right angle, so I know that means it's 90, I need to figure out how much this is. Okay, so I need to figure out 90 and 75 and what make 180? Well, I know that 90 and 75 make 165. 165 plus what makes 180? Well, this here should be the difference between 165 and 180. So to find it, I would do 180 minus 165, and I would get 15. Okay, so here it should be 15. In place of a line, let's put 15. So this angle, lambda, should be 15. And if it asks how you found it, well, I found it like this. And the answer is 15. Next up, actually, no, wait, this was, no, this is it. This is it, right? Yeah, this is it. This is, again, on Wednesday. This was a Wednesday exercise. Now, let's see what we have here. This is theory. This is an example. So let's try this. Now it says that m is 30. Okay, let's write that down. M is 30. And then it wants us to measure lambda with a protractor. So I have taken my protractor here from the previous exercise, and I've made it a little bit see-through. Okay, so we want to measure what? We want to measure lambda. So let's rotate this a little bit so it can touch this side, and we can see that we're going to have to start from here. So the 0 is here, and we're going to have to go all the way here up at 100 degrees. So lambda is 100 degrees. Let's write that down as well. And then it asks us what is the value of kappa. So that this angle up here. Well, since I know that these are 30 and 100, I would say 130 plus what gives me kappa? Or I could say that 130, which makes 130, so 100, we need to make that a little smaller. 130, which makes 130, and then find the difference of that and 180. So 180 minus 130, which would give me 50. Also, it asks what, also it asks the value of the lambda angle that we measured as 100 degrees, and it also asks what kind of triangle this is. Now, since it has this angle right here that is more than 90 degrees, that would make it an obtuse triangle. Obtuse triangle, or in Greek, amblygonio. Okay, let's hide the protractor for a bit. Now, here we go. I know that P is 35, so this angle is 35. I know that rho is what? Without measuring it, you can see that this is a right angle. So that's got to be 90 degrees. Okay, so in order to find sigma, I would do 100 minus the sum of these two. So 35 and 90. So 35 and 90. 35 and 90 makes 125. So I would do 180 minus 125, which gives me 55. So sigma is 55 degrees. Also, this triangle, as it has one right angle right here, that makes it a right triangle, or in Greek, orthogonio. Orthogonio trígono. Next up, this is one of Thursday's exercises. This only has theory, so I'm going to close it. Yeah, yeah. Also, oh, yeah, I shouldn't have closed it actually, because I wanted to tell you that if you wanted to, you could have cut out the protractor. You could have cut it out with some scissors and used that as a protractor if you needed to. So, next up, because here, for example, you need protractors. So that's what you do if you don't have one at home. Let's actually take the protractor that we had here, move it over to the other exercise here, because this one wants us to, um, well, actually, no, we don't really need it. It just wants us to define them as either right, obtuse, or acute. So we can do that with the eye. We don't really have to use a protractor for this. We can do that with just our eyes. This is 90 degrees right here, right? This is a right angle. Okay, so here I would write angle, or in Greek, right? This is more open than that, so it's obtuse. Yeah. Sorry, I just need a second to make sure I remembered how it was spelled. Yeah. Now, this one is more closed than the right angle. It's much smaller. It's a much smaller angle. So this one is acute. Or in Greek, oxia. Next up, it wants us to fill up the board, basically write what each of these angles is. So let's first find our acute angles, the ones that are smaller than a right angle. So that would be this one, this one, this one, and this one. So that's A, B, E, and C here. Alpha, beta, epsilon, zeta. Alpha, beta. Oh, no, sorry. I'm putting them in the right angle. I just saw the O and got confused. zeta. So those are my acute angles. Next up, okay, my right angles are 1 and 2, right? I don't have any more. Yeah, so that's gamma and epsilon. Another one. Oh, this is a mistake. Well, let's just correct this. We'll put another letter here. We'll put iota. So this has to be iota. And next up, lastly, we have our obtuse angles. So 1, 2. So delta and sigma tau. And that is exercise 3. Yep, that's all of exercise 3. And now we move on to exercise 4. Exercise 4 says, without using a protractor, I'm going to write the kind of angles that I have here. So again, if it's less than 90, it's acute. If it's equal to 90, it is right, or let's just write in Greek here. If it is greater than 90, it is obtuse, in Greek, amblia. So let's get writing. Here, you know what we'll do? You know what we'll do? We'll do all the right angles first. So this one is right. So we're going to write right angle in Greek. And then, wait, no, that was a mistake. That shouldn't be there. And then what we're going to do is we're going to copy that. I'm going to put it here where there's another right angle. Right here, you can see it. And are there any more right angles? I don't see any. Okay. So here we have an acute angle, or in Greek, oxyagonia. So we have another one here, 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 definitely. Yeah, that's about it. So let's get copying. One here, one here, one here, and one here. Actually, no, I don't like this placement. There we go. Then we need to talk about the obtuse angles. So now we have the obtuse angles that are bigger than 90 degrees. So this one is obtuse. In Greek, amblia. And then I'm going to take this and copy it here. And here. And this one, if you remember, now this is a little bit of an extra. If you remember, we said it from last time, this is actually called a straight angle. We can just say fail. So that's exercise 4. That'll be all for today. Have a good weekend. Do your homework. And See you guys on Monday. Bye.